In this particular video, we are going to work with what are known as rational functions. And our goal is to learn how to find both vertical and horizontal asymptotes. So starting with your vertical asymptotes, in order to find vertical asymptotes for a rational function, you are going to take the bottom of the fraction and set it equal to 0. Okay, so basically, when we say rational function, the word ratio simply means it's a fraction. And so a fraction has both a top that we call the numerator and the bottom, which we call the denominator. So you're going to set the bottom equal to 0 and solve it. Whereas when you are looking for horizontal asymptotes, you are going to have one of 3 cases. So the first case is what I refer to as the fraction being top-heavy. And that simply means that your degree of your x on top is biggest. So degree just means the highest power of x. And if your highest power of x on top is your biggest, that tells us we do not have a horizontal asymptote. There are cases where you could have an oblique asymptote if the degree is exactly one more on top than it is on bottom, but that is beyond the scope of this course that we're doing right now. So we're just going to say no horizontal asymptote. The second case is the fraction could be what we refer to as bottom heavy, meaning that my degree of x on bottom is biggest. So again, degree is the highest power of x that you are seeing. And if that is the case, we say the horizontal asymptote is y equals 0. And it is important to note you have to put the y equal as part of the asymptote because it is a horizontal line. Now, the third case is if the what we call equal powers, simply meaning that your degree on top is equal to your degree on the bottom. And when that is the case, you do have a horizontal asymptote. We say that it is y equal, and we're just going to call it a over b. And the a and the b refer to coefficients of your x with the highest power. So the a is the coefficient of the x on top with the highest power. The b would be the coefficient on bottom for that x that would have that same highest power. So now let's take a look at some examples. In this first one, we are looking at -9 divided by x plus 3. So I'm going to start with the vertical asymptote. These questions will have 3 steps, so they'll start with vertical. So we take only the bottom of the fraction, and we're going to say, or set x plus 3 equals to 0 and solve it. So if I'm getting x by itself, I'll subtract 3 on both sides, and I would say in this case my vertical asymptote is x equal -3. Now, for the horizontal asymptote, remember I'm looking at the highest powers of x on top and bottom. So notice there is not an x in the top part of this fraction. So the power of x would be 0 since it's not there, whereas on bottom the power of x is a 1. So in this case, I would say that because the higher power of x is on bottom, I would say this is bottom heavy. And anytime a rational function is bottom heavy, then your horizontal asymptote becomes y is equal to 0. Okay, as I look at the second example, again, starting with my vertical asymptote, I only look at the bottom. So x plus 4 is my expression on bottom. I set it equal to 0, and I solve it. Getting x by itself, I would subtract 4 on both sides. So my vertical asymptote is x equals -4. Now, you'll notice for the horizontal asymptote in this case, when I look at my power of x on top, it is x to the first. And when I look on bottom, it is also x to the first. So this is a case where I say they have equal powers. The degree on top is equal to the degree on bottom. And when this is the case, I'm going to look at the numbers in front of the x. So on the top, I have this -3 in front of the x. And on bottom, I have what's understood to be a 1. So I make that ratio, and in this case, my horizontal asymptote, when I simplify, -3 divided by 1 would give me a horizontal asymptote of y equals -3.